Welcome, dear listener. Wherever you are in the world, whether you're in a quiet village tucked between hills, a city apartment glowing with nightlights, or a cozy room filled with the soft hum of evening, I'm so glad you're here. Before we drift off into tonight's gentle story, take a moment to subscribe to the channel so you never miss another peaceful bedtime journey. Okay, your support truly means the world, and it helps this calm little corner of the internet grow. Now, close your eyes, breathe in deeply, and let's begin the journey. In the beginning, there was stillness. The earth rested beneath a quiet sky. The trees stood motionless, and the cool night air flowed softly across the land. It was the kind of night that seemed to pause time, calm, open, and full of gentle mystery. Yet within this stillness, nature held a quiet secret, an ancient and powerful rhythm of transformation waiting to awaken. Now imagine yourself in a peaceful forest clearing. Far from the noise of the world, stars above shimmer like tiny lanterns scattered across a deep blue sky. A soft breeze rustles through the leaves. You are not alone, but not in the usual sense. Nature surrounds you like a warm, watchful presence. In the center of the clearing lies a circle of stones. Nestled inside is a small pile of twigs, dried leaves, and soft, golden moss. You sit beside it, calm and unhurried, holding two stones in your hands. You strike them together, once, twice, and on the third time, a tiny spark flies out. That flicker, small, golden, and fleeting, lands gently on the moss. It doesn't catch immediately. It dances, trembles, then disappears. You try again, another spark. This time, the moss darkens at the edge. A curl of smoke lifts into the air. And then, finally, light. A flame is born. It glows softly at first, no bigger than the eye of a firefly. It breathes in the air around it, hesitating, then growing. The dry twigs begin to blacken and crackle. The flame reaches upward with delicate yellow fingers, stretching and swaying like a ribbon in the wind. It is alive now. But how? This is where our journey truly begins. The story of fire and the invisible force that gives it life. Oxygen, to understand fire, we must travel into a smaller world. A world far too tiny to see, yet so full of movement and wonder. It's the world of molecules and atoms, building blocks of everything around us. You might think fire is simply a flame, a glow, a patch of light and heat, but it is much more than that. It's a conversation, one that happens between tiny particles, unseen by the eye, but full of power. It's a beautiful and delicate process known as combustion. Combustion happens when three things come together. Fuel, something that burns, like wood, paper, or oil. These materials are made mostly of carbon and hydrogen, both rich in energy. Heat, enough warmth to get the process started. Spark, a match, or even the sun. Oxygen, a colorless, invisible gas in the air. We breathe it every day, and so does fire. You may have heard of something called the fire triangle. Fuel, heat, and oxygen. Each side of the triangle supports the other. Remove one, and the flame disappears. Tonight, we're focusing on oxygen, the breath that gives fire its life. Let's imagine what happens, slowly and gently, when a twig begins to burn. As the flame touches the wood, it heats the molecules within. The carbon and hydrogen in the wood are held together by strong bonds, like little hands clasped tightly. But with enough heat, those hands begin to let go. The bonds break. The carbon atoms are suddenly free, looking for a new partner. The hydrogen atoms drift apart, also seeking something to bind with. And floating all around, in every breath of air, are molecules of oxygen, each made of two tightly connected oxygen atoms. The freed carbon meets oxygen. They join hands. Together, they become something new. Carbon dioxide, a gas that gently floats away into the night. Hydrogen, too, finds its match. It combines with oxygen to form water vapor, which rises invisibly into the sky. And in this beautiful dance of bonding and transformation, something magical happens. Energy is released. This energy becomes heat, which keeps the fire going, and light, which glows from the flame. Every flicker you see, every soft crackle you hear, is the result of millions of tiny atoms joining together in this quiet, powerful reaction. No oxygen, no bonding, no bonding, no fire. That's why a flame fades when you cover it. The fuel is still there. The heat remains for a little while. But without oxygen, the fire loses its breath. It sighs, it dims, and it gently goes out. As we lie beneath the stars and listen to the soft crackle of firewood, it's almost strange to think that something as invisible as air can be so essential. We can't see it, we can't hold it, yet within every breath, every breeze, every whisper of wind lies the power to give life or to take it away. Air is not empty. It's a blend of many gases like nitrogen, carbon dioxide, and trace amounts of others. But floating among them is a very special one, oxygen. It makes up just over 20% of the air around us, and it is the gas most responsible for sustaining both life and flame. It's curious, isn't it? It's the same element that keeps us alive. Breathing, moving, thinking is also what allows fire to burn. We are, in a way, made of the same breath that fuels the flame. Imagine now that you're floating, slowly, through the air itself. You drift between molecules, some big, some small, some spinning like tiny tops. The oxygen molecules hover like twin dancers, always in pairs, moving gracefully, ready for the next connection. They're not aggressive or forceful. They're simply waiting for the right moment to bond, waiting for the invitation that heat provides. When a flame starts, it's as if someone rings a silent bell. The oxygen hears it. The molecules rush in. They meet carbon and hydrogen with a soft embrace, and in that union, a flame flickers to life. And so, it's every fire you've ever seen, every candle, every campfire, every glowing hearth is not just a source of warmth. It is a meeting place, a moment of chemistry, a place where the invisible becomes visible, where molecules find each other in the darkness and turn their union into light. Now, let's look closer, not just at the flame, but within it. Notice how it moves softly at first, swaying gently like a slow breath. The base glows blue, the middle yellow and gold, and at the edges, a faint orange or red. It's a slow dance of color, constantly shifting, never still. But why does fire have color? The answer lies in energy. When the atoms and fuel begin to break and reform, when carbon and hydrogen combine with oxygen, they don't just release heat, they also release light. The energy from the reaction excites other molecules, making their electrons jump to higher levels. But electrons don't like to stay up there. They fall back down, and when they do, they release tiny packets of light, called photons. The color of these photons depends on the energy involved. Cooler flames may glow red or orange. Hotter parts, like the base, burn blue. The blue part of the flame is actually the hottest, even though we often think of red as hot and blue as cold. Some flames even change color based on the material. Burning, add salt, and you might see yellow. Copper can create green or blue hues. Lithium gives pink. These aren't tricks or magic. They're windows into chemistry. So each fire tells a story written in color, a tale of atoms dancing, leaping, transforming, visible for just a moment before fading into the air. As you stare at the flame, slowly blinking, breathing deeper, you might begin to feel that the fire is telling you something, not in words, but in warmth, light, and movement. It's a lullaby made of science. Let's imagine something gentle. The fire in our forest clearing is beginning to shrink. not from cold or fear, but simply because its oxygen is running low. A soft breeze has stopped. The night air is still. The flame begins to quiet. It no longer reaches up. It curls inward. The yellow turns to orange, the orange to red, and finally, a glowing coal. But why does this happen? As fire burns, it consumes oxygen from the surrounding air. The molecules are pulled into the reaction, transformed, and released again, this time as carbon dioxide and water vapor. But if fresh oxygen cannot flow in, if there is no breeze, or if the fire is trapped in a sealed space, it begins to suffocate. Without oxygen, combustion can't continue. The fuel remains, the heat lingers, but the reaction slowly starves. Light flickers, the warmth fades, and the flame whispers its last breath. There's no panic in the flame, no violence, just a quiet return to darkness. And in that stillness, something beautiful remains, the glowing memory of what once was. The charred logs, the warm coals, the soft smoke curling upward like a dream. It reminds us that fire is never permanent. It is always moving, always changing, dependent on balance. Just like us. Now, let's step back in time, far, far back, to a moment when fire first entered the human story. Thousands of years ago, long before cities or books or science as we know it, people lived in a world ruled by nature. The nights were cold, the dark deep, and the stars were the only light in the sky. But one day, whether by lightning or volcanic spark, fire appeared. At first, our ancestors feared it. The flame was wild and unpredictable. It danced and destroyed. It roared and flickered and hissed. It was beautiful, yes, but also untamed. But then, someone got closer. Someone noticed the warmth, the light, the protection it offered against predators and the cold. And slowly, very slowly, people began to understand this strange, glowing thing could be tamed. It could be fed and cared for. It could be used, not just to survive, but to thrive. From that point on, fire became one of humanity's most sacred tools. It cooked food, making it safer and easier to digest. It kept the night at bay. It warmed caves and huts, lit the first lamps, forged the first metal tools, baked the first bricks. But none of this would have been possible without oxygen, even though early humans didn't know about molecules or atoms. They knew instinctively that fire needed air. They would blow gently on a spark to feed it. They would fan the flames to help them grow. They didn't know word oxygen, but they knew what it meant to breathe life into a fire. So fire and humanity walked forward together. A quiet companionship woven into our story. Let's gently float forward in time. Past ancient fires and stone tools, past wooden ships and candlelit halls, to a moment of curiosity. A time when people began to ask not just what fire is, but why it behaves the way it does. In the 1700s, scientists began experimenting with air. At the time, the idea of elements was still forming. People knew that fire needed something, but they weren't sure what. Some believed in a theory called phlogiston, a mysterious substance they thought was released during burning. But that theory, while poetic, didn't quite explain everything. Then, in the late 18th century, a quiet breakthrough occurred. A man named Joseph Priestley, an English scientist and theologian, conducted a gentle experiment. He heated a substance called mercuric oxide and collected the gas that was released. When he placed a candle into this gas, it burned brighter and longer than it did in normal air. He had found something special. Another scientist, Antoine Lavoisier, took Priestley's discovery further. He studied the process of combustion carefully, noting the exact changes in weight and air. Through detailed, thoughtful experiments, Lavoisier discovered the truth. This gas wasn't just helping the fire, it was essential to it. He named it oxygen, from the Greek words oxys, acid, and genes, creator, because he believed it was involved in the creation of acids. Lavoisier didn't just discover a gas, he gave the world a deeper understanding of fire. He explained that combustion wasn't about releasing phlogiston, it was about combining with oxygen. It was chemistry in action, molecules breaking and bonding, releasing energy and transforming the world around them. Thanks to his work, we began to understand not just how fire worked, but why it burned. And so, the story of fire and oxygen was no longer just a mystery of nature. It became a science of wonder, a language we could speak, a force we could study, predict, and respectfully control. Stillness of the flame now. Let's return once again to the present, to you, lying safely beneath your blanket, the soft hum of nighttime surrounding you. Your breath is slow, deep, and even, and before you, a small, peaceful fire. It crackles gently. No rush, no need, just presence. You now know what makes it burn. You've traveled into the world of molecules, touched the edge of a carbon atom, drifted beside oxygen in the air. You've watched them meet, join hands, or release their energy in the soft golden glow of light. You've seen how fire breathes and how, in a way, it mirrors us. Like us, it needs fuel to feed it. Like us, it needs warmth to thrive. And just like us, it needs air, the soft, invisible life that keeps everything in balance. Without oxygen, fire fades. But with it, the flame dances. And now, that dancing light begins to quiet once again. Not because it is gone, but because it is ready to rest. Just like you, the flame flickers. You can almost feel its warmth against your skin, even now. It's not just the warmth of fire, it's the warmth of memory. You see, fire didn't just keep early humans alive, it helped shape the world we live in today. It was the first technology, the first teacher, the first partner in progress. Long ago, when people learned to carry fire with them, they no longer had to fear the cold. They could live in new places, travel farther, stay up through the night. They created hearths, places where fire lived safely inside the home. These fires became the center of families, communities, and culture. Later, we learned to shape metals with fire. By burning wood or coal and blowing air into the flames, people created furnaces, much hotter fires that could melt ore and forge it into tools, armor, coins, and machines. It was oxygen drawn in through the bellows that made these fires so strong. More oxygen meant more combustion. More combustion meant more energy, and more energy meant possibility. With controlled fire, humanity baked clay into bricks, turned sand into glass, and powered the first steam engines. Every spark of innovation came from a real spark, born of heat, fuel, and air. Even today, fire lives within our world in different forms. In engines, in rockets, in laboratories, in candles. It's quieter now, more contained. But the truth remains. Oxygen is still at the heart of it all. That soft, invisible gas, the one you're breathing now, is the key to everything, from a glowing lantern to the stars in the sky. Yes, even the stars. As you lie there, your eyelids heavier, you're breathing slower. Look up. Imagine the night sky above. The stars, thousands of them, blinking gently in the vast quiet of space. Did you know those stars are also flames? Well, not flames like the one in our clearing, but similar. Stars are massive spheres of burning gas, mainly hydrogen and helium, undergoing a kind of nuclear fire. And though the process is different from chemical combustion, the result is the same: light, heat, and energy. Stars burn because of fusion, but they need fuel, just like our tiny fire. And while they don't need oxygen the way we do, they are part of the same cosmic story. The oxygen in our air, the carbon in our wood, the hydrogen in our water. All of it was born inside stars. Billions of years ago, a star lived and died, and in its final breath, it scattered these elements across space. Eventually, some of them came together to form Earth, and you and me. In the fires we build. So when you light a flame, you are not just warming yourself. You are awakening ancient stardust. You are continuing a chain of energy that began long before humans ever walked the earth. Isn't that beautiful? Let's return one last time to the forest clearing. The fire has grown smaller now. It's not gone. It's just resting. The flames have softened into red coals, glowing quietly beneath the ash. There's no fear in this ending, just peace. The oxygen in the air has done its job. It's joined with the carbon in the wood, released heat, created light, and told a story. Our story. You've walked through the chemistry of fire tonight. You've seen how atoms break and bond, how flames change color, how combustion becomes light, okay? And how all of it is only possible because of oxygen, the invisible breath that surrounds you now. You've traveled through time, from the first spark in a dark cave to the giant stars that forged the elements in your body. And you've done it gently, slowly, letting each thought drift past you like smoke rising into a quiet sky. Now, it's time to rest. Let the final embers fade behind your closed eyes. Let your breath become the only rhythm you hear. In, out, slow, safe, and as you drift into sleep, remember, the fire will always return. It's never truly gone, just waiting, okay? Waiting for warmth, for fuel, okay? And for a whisper of air to fire. Like you, is patient. Good night, dear listener. Sleep well, and thank you for letting me share this journey with you.